Okay, learners. So in this session, I'll be discussing with you the introduction to internet addressing. As I have already discussed with you that the transmission of packet from one computer to another computer or one network to another network takes place on the basis of source address and destination address. But there are certain mechanisms, certain ways of giving addresses to the devices which are part of the network. And we have already seen that one kind of address is MAC address. So in our previous discussion, we have seen what is MAC address. Another important logical addressing is there, which is known as IP addresses, subnet address, and many more. So I am Professor Asim Zafar, and today I'll be discussing with you about internet addressing. What are the various types of addressing schemes which are used in a computer network or on the internet. So internet addressing involves using a specific identifiers to locate and manage devices and resources on the network. So all the devices which are part of the network, they must have a unique address. Then only it will be possible to deliver a message from one device to another device. What are the key or various types of addresses which we will discuss is known as MAC address. This is a unique identifier for network interfaces. I have already showed you every NIC card, network interface card, has a unique address. If they are put on the computer, then we start saying that this is the MAC address of the computer, fine. But essentially speaking, it is the address of the MAC card which is inserted in that particular computer, or NIC card, I mean to say. Another logical addressing scheme is known as IP addresses. It identifies devices on the network for data routing. So all the devices which are part of the computer network, they have a unique IP address, Internet Protocol address. So how these addresses are written, what is the format of these addresses, we will discuss in the latter part of the discussion. But all the devices which is part of the network must have a unique IP address. And subnetting. Subnetting basically divides a network into a smaller subnetwork so that the delivery of the message becomes easier for the protocols. Importance, it ensures effective communication and management of network devices. You see here, we will start our discussion with MAC, and as I have already told you that it is a 48-bit address basically, which can be divided into 6 octets, each containing 1 byte or 8 bits, whatever you may call it. You just see here, the format is given over here. Starting from first octet, second octet, third, fourth, fifth and sixth, each of 8 bits. So 8-bit octet is there. All the addresses are in 101010 form. I mean to say in binary form basically. But I have already told you that it is very difficult for the human being to remember all these addresses. So better we use this kind of addressing scheme, which is comparatively easier for the human being to remember basically. So these are the formats of MAC address. So a MAC address is a unique hardware identifier assigned to a network interface card by the manufacturer. So every manufacturer is manufacturing, and several manufacturers are manufacturing NIC card, but they are taking into the consideration that each NIC card, no matter whether it is produced by one manufacturer or being produced by another manufacturer, will have unique MAC address. As far as the format is concerned, I have already told you that it is 48-bit address represented as 6 pairs of hexadecimal digits. You see here hexadecimal digits. It is easier for us to remember. From 0 to 9, it is 09, but hexadecimal we go up to from 0 to 15. So for 10, it is A. Similarly, for 11, it is B. For 12, it is C. For 13, it is D. For 14, it is E, and F is for 16. So any number like that, maybe depending on the address will be that. So it will look like that: 1F, 2, 9, maybe 3, C, D, F, 6, and maybe B, 2, like that. So all are possible, all are valid. I mean to say all are valid. This may be the format of MAC address in hexadecimal format, and most of them we use this kind of things because it is comparatively easier to remember. The first 3 pairs here identify the manufacturers. You just see here, first 3 pairs, they identify the manufacturer. Fine. So, 3 byte. So, maybe produced by HP, maybe produced by Dell, maybe produced by any other company, DEC. So, the first 3 bits or bytes basically is used for what? Identification of the company or manufacturer, and the last 3 pair specify the devices, and they produce unique number, some unique number, combination of unique number. So, here 3 bytes are there. 3 bytes means you can understand it is 24. So, 2 to the power 24 unique addresses may be there, in combination. So, a large number of devices are there. So, large number of space is there, I mean to say, to identify the devices. It uniquely identifies devices on the same local network and operates at the data link layer of the OSI model. So, it operates on the data link layer. What is the data link layer? What is the physical layer? I will discuss it in the latter part of my discussion. So, role in network communication, it ensures that data sent over a local network reaches the correct destination device. It is used in Ethernet network to determine the source and destination of each data frame. There are various types of MAC address, you can say. Unicast MAC address. Unicast means it is used to send data to a single specific device. If it is known as, in that case, it will be known as unicast. Sometimes it is multicast MAC address. It is used to send data to a group of devices. It's a group devices here. So, a group ID is there, and say for example, 4 or 5 computers belong to a certain group, and you do have a group ID. So, whenever the message will be sent to that group ID, it will be sent to all the members of that group. In that case, it will be known as multicast address. And sometimes it is required that the message must reach to all the devices which are part of the network. Say for example, you want to give the alarm signal that there is a fire in the company, all of you are required to exit from the company. So, here it is required that the message must reach to all the computers, all the parts, or all the devices which are part of the network. In that case, it will be known as a broadcast address. And what is that address? FFFFF, all F's are there. So, if in the address it is written all F, then the message will be given to all the computers, no matter what is their MAC address. So, all the computers will receive this message, and accordingly they can take the decision. One protocol is there basically, which is known as ARP. I have already told you that whenever there are certain communication, they always communicate, the devices always communicate based on certain rules and regulations. They are known as protocols. One protocol is there which is known as ARP, Address Resolution Protocol. So, ARP is a protocol used to map an IP address to MAC address. I have already told you that in the network, in the whole network, I mean to say the bigger network, internet, the message travels on the basis of what? IP. Means routers are sending the message to your network based on IP address. So, okay, the moment it reaches to your network, you may find that there are several computers over here. So, the message has reached up to this point, but whenever on the basis of IP addresses. But here, after reaching to this place, it finds that there are 4 people which are connected to this network, to whom it should be transmitted. Then this protocol comes into picture, which is known as ARP. So, ARP provides a mapping between IP address and MAC address. Fine. So, say for example, it manages a table, and here you see corresponding to this IP address, say for that the network responds that this computer has this particular IP, which is this MAC address. So, this IP is bound to this MAC address, then the message will be transmitted to this computer. Sometime it may happen that this IP is mapping to this IP. That is decided by ARP. ARP tells you exactly which MAC address is bound or is binded to a particular IP address or maps to a particular IP address. So, this is done by ARP protocol. So, ARP protocol helps you here to map the IP address with the MAC address, so that the correct delivery may be ensured to which computer it should go. So, when a device wants to communicate with another device on the same network, it sends an ARP request to find out the MAC address associated with the target IP address. The target device replies with its MAC address, enabling communication to. So, it is telling you how ARP works basically. So, ARP, what happens whenever a IP packet is received over here, it broadcasts a message that please tell me your MAC address whose IP address is this. It is just like calling the roll call. Say for example, I am calling roll number 13. So only the message, though the message will be received by whole class, but only roll number 13 will reply back either yes or whatsoever. Yes, sir. So similar is the case over here. A broadcast message is done by the ARP telling them, please tell me or please inform me your MAC address whose IP address is this. Then only this message will be received by all because it is broadcasted. So only this will reply because this has the same IP address. It will reply back by sending their MAC address to the switch. The moment MAC address is received by the switch, that message will be sent to that particular computer. So this is how the message is delivered using ARP protocol. And what is the importance? So it ensures data packets reaches the correct device by converting logical address, that is the IP address, to the physical address, that is the MAC address. Because I have already told you in my previous discussion that at the local level and the switch level, basically the transmission takes place with the help of MAC address. So to which computer it will go, to decide that you should know the MAC address. And how the MAC address will be known to you? By the ARP protocol. So ARP protocol will broadcast a message, please tell me your MAC address whose IP is this. I have already told you IP is a unique address. So say for example, this will reply by sending its MAC address. The moment switch gets the MAC address, accordingly the message will be transmitted to that particular destination. So this is how transmissions takes place with correct transmission takes place with the help of ARP. Now a very important protocol of the TCP/IP suite. TCP/IP is the name of a protocol suite, is IP, Internet Protocol. So we'll discuss what is an IP address. And of this protocol, IP protocol, main component is IP address. So an IP address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol or Internet Protocol for communication or for transmitting the message from one place to another place. So this IP protocol uses IP addresses. And what is IP addresses? I have already told you, it is logical address basically. It is not the physical address. Physical address is the network NIC address, means MAC address is the physical address. They are known as, but each and every computer which is part of the network must have a unique IP address, that logical address. And the format of IP address, I have already told you that it is a 32-bit. 32-bit means 4 octet, 8 bits, 8 bits, 8 bits and 8 bits, 4 octet message, total 32-bit message. I have already told you these are in the binary form 100, 100 and like that. So these messages are like that, these addresses are like that, but it is very difficult for the human being to remember the address in this form. So we use basically the decimal octation, and for decimal octation it may be like something like that, 192.168.24.32. So anything between 0 to 255 for every octet is the valid number, 0 to 255. So is a valid number. So types of IP addresses, there are 2 types of IP addresses. One is known as IPv version 4. So currently in most of the setup we are using IPv version 4. Now we are in the process of converting or changing or we can say transiting from IPv version 4 network to IPv version 6. So IPv version 4 networks have 32-bit addresses represented as 4 decimal numbers separated by dots, as I have told you over here. But with the increase in the devices, number of devices and the networks basically, that space is no longer enough to meet the increasing demand of the, so we need some bigger namespace, I mean it's a large number of IP addresses. For that we are migrating to IP version 6, which allows you to have 128-bit address instead of 32-bit address. So with 128 bits we do have many possible combinations, many unique addresses, and that are nowadays enough to meet the increasing demand of number of networks or computers. So they are represented as 8 groups of 4 hexadecimal digits separated by colons. What is the purpose of IP address? It provides unique identification for devices on the network and facilitates the routing of packets across the network. I have already told you the routing takes place on the basis of IP addresses. So router on the level of router, that is on the network level, they perform the duties on the basis of IP addresses. But when it reaches to the switch level, to the endpoint level, then it is converted back, IP address is converted back to MAC address with the help of ERP protocol, and the correct delivery of the message is ensured in this way. Here is basically, you can see the format of the IP addresses. I have already told you. So, an IPv version 4 internet protocol, in what happens in IPv version 4, the structure of IP address is 32-bit address. It is divided into 4 8-bit section called octets. I have already told you each octets may range from 0 to 255. So, octet means 2 to the power 8, maximum 2 to the power 8 combination will be there. So, 256 combination. So, always starts from 0, it goes to 255. So, 0 to 255 maximum value may be there. This is the value, any value between these for all the octets, I mean to say. For the sake of convenience, basically, these addresses has been classified as class A level network, class B, class C, class D, and class E level. So, for very large networks, basically, which are having many numbers of nodes which are connected with the network, we do have class A network. What is class A? I will tell you, it is used in a large number. In medium-sized networks, we use class B network addressing address. While for smaller networks, we do have class C networks. While for multicast address, we use class D addresses, and class E is currently an experimental one. You just see here, how many octets are there? 1, 2, 3, 4. So, out of these 4 octets, basically, we use 1 octet. If you are using 1 octet for network ID, there are 2 things of every network is having a unique ID, and all the devices connected to that, they are having the unique ID. So, you see here host ID. So, there are 2 parts basically, the address, 4-bit address. So, say for example 8 bits and 24 bits. If you are using 8 bit to identify network and rest of the 25 you are using to identify host, if this is the situation, if you are configuring your network in this way, then it will be known as class A network. So, you just see here, with this 24, how many different computers may be there in a particular network, in a particular 2 to the power 24, which is very high basically. That is why it is said that it is used for large networks. While another situation may be there, that is okay, oh, sir, we do not have that much amount of nodes per network basically. Hardly we do have 100, 200, 300 nodes per network. So, why do we use this thing? Another scheme, yes, another scheme is there. So, in another scheme, what you can do basically, so say for example, 16 bits here and 16 bits here. So, this is used for network ID, for net ID, this is used for host ID. So, okay, again, still we do have 2 to the power 6 different combinations for every host. So, that is also a good. So, for medium sized network, it is used. If you are using this scheme of addressing, then it will be known as class B. No matter whether you are using class B or class C, all the addresses will be represented in binaries basically. Another situation may be there, sir, still it is very big number. So, why don't you do like that? I am using 24 for network because there are so many networks, network ID, and 8 I am using for host ID. For 8 means 2 to the power 8. Still we can use 256 devices per network. That is very good number. So, that is why for a small network we use class C. This is known as classical classification. Fine. But whenever these things are represented in the binary form, if the number starts from 0, the moment you see the address is starting from 0 in the binary, if the numbers are represented in the binary segment, 32-bit binary digit, if the number is starting from the, similarly you can identify that this is a class A network. If the number starts from this number A0, 10, and rest of the things are whatever numbers are there, if the starting number is this, then you can say that it is class B address. I am just telling you how we can identify the address, whether it is class A, class B, class C, fine. Similarly, if the address is started from 110, the first 3 bits for all the segments are 110, then it is class C address. If it is 1110, then it is class D address. If it is all 1, the 4 bits in all ones, then it will be known as class. So, by seeing the binary representation of the IP address, if the IP addresses are mentioned in binary, you can easily say that to which class this address belongs to. Another is IP version 6. I have already told you that in IP version 6, instead of having 32 bit, we do have how many? 128 bits to represent the address. So IPv version 6 is the next generation internet protocol designed to address the limitations of IPv version 4. So it is composed of 8 groups of 4 hexadecimal numbers. 8 groups of 4 hexadecimal digits separated by colons. So they are represented in this way. That is, it is easier for human being to represent these numbers. You just see here. This is the hexadecimal IP address format basically. So 1, 2, 3, 4, 5, 6, 7 and 8. So 8 groups of 4 hexadecimal numbers are there. Just like in our IP addresses, IPv version 4 IP address was 32 bit. 32 bit means 4 octet were there, and each was in decimal number basically. Maybe 162, maybe 92, maybe 32, maybe 48. So all the octets are written in decimal. But here we represent all the 8 octets in hexadecimal number. So it allows you to have a vast address space to accommodate future internet growth. I have already told you that with IP version 4 it was limiting the number of devices, because a lot of number of networks and devices are coming up, and these were not enough to meet the addressing needs of the growing networks. So to meet all these, we do have vast address space to accommodate future internet. There are built-in security features such as mandatory support for IPsec. So not only addressing scheme is different, but in IPv version 6 there were some limitations, some demerits of IPv version 4 that was also taken care in the IPv version 6. And right now we are in the process of transmitting or going from IPv version 4 to IPv version 4. So still you will find that many networks are using IPv version 4. Nowadays many of networks are using IPv version 6 as well, and they can seamlessly communicate with each other using the help of gateways and routers. You just see here gradually being adopted alongside IPv version 4, especially in new networks and devices. Another thing is there which is known as subnetting. What happens in case of subnetting basically? So subnetting is the process of dividing a larger network into a smaller, more manageable subnets basically, more eligible subnets. If you divide a larger network into the smaller one, it becomes easier to manage that network, and the process of data delivery becomes easier. So efficient IP allocation, it reduces the wastage of IP address, improves security, isolates part of the network to control traffic, and better performance. It reduces network congestion by limiting broadcast domains. It defines which part of an IP address is the network portion and which part is the host portion basically. Say for example, I'm just telling you for example over here, you just see, say a B class address is there. What happens in B class address? B class address, 16 bits are here and 16 bits here. They are used for net ID, they are used for host ID. 8 host ID. You can say, sir, 2 to the power 16 is very big number. We don't have that much computer per network, I mean to say. So, okay. Then why don't you use this portion as subnet ID? Subnet ID. So the information first will reach to this network, whatever number is there, net ID. There they can find that, okay, in this network there are several smaller networks are there, and each smaller network have these kinds of numbers denoted by subnet ID, and every subnet is having certain computers or certain devices connected to it. So if you have 3 level of architecture instead of 2, initially we have 2 level of architecture, net ID and host ID. Net ID and host ID. What you are doing by subnetting? You are having net ID. Here you are having one more thing, subnet ID and then host ID. So if we have 3 level of addressing scheme, the process of delivery of the message is becomes easier. Say for example, I'm taking, there is one thing written over here. A packet is there, a parcel packet is there, and that is to be delivered. Say for example, Mohan Aligarh or Mohan Kumar Aligarh. Only 2 level of addresses are there. Mohan Kumar host ID and Aligarh is net ID mainly. So 2 level of addresses are there. Then it will be very difficult to deliver that packet. First of all, in the whole Aligarh, you will have to search for Mohan, and if you find the Mohan, then you will have to deliver the message. But if I increase level of the addressing, one level up, I am telling you Mohan, Gulshan Colony, Aligarh, then you need not to search the whole Aligarh area. Simply you will go to Gulshan Colony, and in that particular colony you will search for Mohan, and you can easily find the Mohan and you can deliver the packet to them. So this happens in case of subnet ID. The delivery of the message becomes much easier. Also, we can maintain smaller networks in a better way, thereby increasing the performance and efficiency of the network. So that is the advantage of subnetting. But now the question arises, okay, sir, here you are telling that we have used 8 bits for subnetting. Sometime anybody can use 6 bit, somebody can use only 4 bits for subnetting. Why all the 8 bits are being used? Yes, it is possible. So it is a local arrangement by the administrator. Then how the incoming packet or incoming message will come to know that how many of these 8 bits are being used for subnetting address. This is told, or this is told by, or this is made them known by what? Subnet mask address. So whenever we provide IP address, say for example it is IP address, it will be IP address, say for example I am taking anything 192.68.32.44 IP address. Just below IP address we do have subnet mask, and here you will have to write 255.255.00. Means these subnet mask tells you how many bits have been used as subnet ID. So here subnet ID will be provided to you, and knowing this subnet mask, the incoming packet may derive whether this has been subnetted or not subnetted, and if subnetted, how many bits are being used. So there is a process for that. I am not going into that detail. Basically IP address and this address is added using the AND operation, and whenever you perform the AND operation, it will give you the subnet ID. So this is how subnet ID is computed by the incoming packet. So it is 32-bit number, this number I am talking about, that masks an IP address. This is a mask an IP address and divides the IP address into a network and host portion. Example 255.255.255 and 00, like that. So basically the binary ones represent the network portion and binary 0 represent the host portion. If it is like that, I mean it's a host ID and it is the net ID. Here in this case it is the net ID, these are the host ID. A subnet mask may be like 255.255.255 and 0, indicates that the first 3 octets are the network part and the last octet is for the host. And whenever you have AND operation with the IP address, it will give you the subnet ID, correct subnet ID you can derive from here. So with this basically we have tried to learn today what is the various schemes of addressing in the network, like MAC addressing, IP addressing, IPv4 addressing, IPv6 addressing, and subnet addressing, like that. With this, basically, we finish this discussion. Thank you. Thank you very much.